Hello everyone, this is the solutions for the second worksheet on chapter 12. Now the first question I've already worked out on my lecture PowerPoints on this chapter, so you may want to refer back to it. At first I thought I would work it out again in this worksheet, but I don't want to duplicate on second thoughts. It's no point wasting time duplicating the same problem again. So if you want to see how this one is worked out, it's also a problem on the textbook. All right. So if you are reading the textbook, you can look it up there. But I've also shown the solutions on the lecture PowerPoint slide for this chapter. All right. So you may want to go through that video as well. Instead, let's go through a different problem here. I mean, it's on the same topic, but with different data values, data sets, and so on. So number 2 here is again a straightforward problem. It's not an application-based problem. It says here, below are the number of successes and the sample size for a simple random sample from a population. Here, x equals 8, n equals 40. Now, these are all hypothesis tests, so they have stated the null and the alternate hypothesis for us and given us alpha, which will represent the significance level at which we will be testing. All right. So, again, chapter 12.2 was on hypothesis testing of one population proportion. So, that's what we are working towards in this worksheet. All right, so the first question is determine the sample proportion. So before you go into actually performing a hypothesis test, you have to calculate the sample proportions. And again, the sample proportions uses the formula p hat equals x divided by n. We have x given to us, which is 8, and n given to us as 40. So 8 divided by 40 is 0.2, and that's our sample proportion. And then we can at the same time find what p hat 1 minus p hat is. So this was the success. We are trying to find the failure, which is 1 minus p hat. That would be 1 minus 0.2, which is 0.8, and that would represent the failure proportion. Okay. Decide whether using the one proportion Z test is appropriate. Of course, the first criterion that must be met is it has to be a simple random sample, SRS, and the second one says n times p sub 0 and 1 minus n times p sub 0 must both be greater or equal to 5. All right. Now, what is p sub 0? P sub 0 is the proportion associated with the null hypothesis. All right. It's p sub 0 is the null hypothesis proportion. So that's given to us as 0.3. And so n times 0.3. All right. So n is 40. So in other words, it's 0.3 times 40 and 1 minus 0.3 times 40 must be greater or equal to 5. So 40 times 0.3 is 12, right? So let's, okay, so 40 times 0.3 comes to 12. So 12 is greater than 5. And 1 minus 12, right? 0.3 times 40, 12. So 1 minus 12 is also, sorry, not 1 minus 12. It should be 1 minus n minus. I made a mistake here. Let me correct that. All right. Instead of 1, it should be n. All right. It should be n minus n times p sub 0. So it should be 40 minus 12. All right. And that's greater than 5 as well. So greater or equal to 5. All right, so it meets all the criteria. Therefore, z-test is appropriate. Z-test is appropriate. Now, since it's appropriate, we can go ahead and perform the z-test procedure. The first step is to state the hypothesis. A null hypothesis has been given to us, and we can just copy it and write it as is. It says P without the hat, because this is the population proportion, and all hypotheses must be stated in terms of population notations. All right, so P equals, null hypothesis must always have an equal sign in it, is 0.3. And the alternate hypothesis, if I recall, says that P is less than 0.3. All right, so H sub A colon P less than 0.3. So based on the alternate hypothesis, this is going to be a left tail test. All right, it's going to be a left tail test. Determine the significance level alpha at which we are testing. It's 0.10. So alpha equals 0.10. If they ask you to draw a diagram, quickly draw a diagram of a left tail test. Okay, so in a left tail test, the reject region is going to be on the left. So it's going to be reject, and then do not reject is going to be the other side of the dashed line, and the area is 0.10. Now, because this is a one tail test, we do not need to split our alpha. All right, so z of 0.10, actually negative z of 0.10 is what our critical value is going to be for this hypothesis test. All right, we will find it later when we use the critical value approach to come to a decision. However, let's move on to step 3, that is finding our test statistic. All right, so the test statistic formula here is P hat minus P sub 0 divided by square root over P sub 0 times 1 minus P sub 0 divided by n. So P hat is 0.2, then minus P sub 0 is 0.3, that's the null hypothesis proportion, divided by square root over P sub 0 is 0.3 times 1 minus 0.3, all right, divided by n is 40. Isn't n 40 given to us? Yes, n is 40. So we have here in the numerator 0.2 minus 0.3 is negative 0.1. All right, and then I'm just going to say 0.10. And in the denominator, we have 0.3 multiplied by 0.7 over 40. All right, and when we do the calculation, we should come up with a test statistic value of negative 1.38. Z sub 0 is negative 1.38. So now we proceed to perform the hypothesis test using the different approaches. So let me just move this to the next page so we get some more space for the critical value approach. So for both of these approaches, you have to accompany your solution with a diagram. So I'm going to first draw the normal curve for the critical value, and it's going to have a reject region to the right. So reject and do not reject, and the area under the curve corresponding to the reject region is going to be alpha equals 0.10. So the critical value, the CV, the cutoff point between the reject and the do not reject region is going to be negative z of 0.10. And when we look up our table or use a graphing calculator, we are going to come up with a value of negative 1.281. All right, so this is the z score is going to be negative 1.281. All right, but you can look up your table, the special z table, to find that value of z. All right, that special z table should be located below the t table. All right, look up some past videos when we were working on confidence intervals and as well as hypothesis test chapter 8 and chapter 9 videos. There I have shown how to use the tables, all right, to find z values, or given a z value, how to find alpha. So let's write clearly what the critical value is. Critical value is negative z of 0.10, which is negative 1.281. Now that we have defined our critical value, bring your test statistic value, which was negative 1.38. So we see that z sub 0 of negative 1.38, where is it? It is less than negative 1.281, the CV value. And it falls in the reject region, falls in reject region. Now show where it falls. It would fall to the left of negative 1.281. So negative 1.38. So show that it falls in the reject region by marking it on your diagram. Falls in reject region, therefore reject, null hypothesis. All right. For the p-value approach, we start with our test statistic value. So start with test statistic z value, z sub 0 equals negative 1.38. So find area to left of z sub 0 equals negative 1.38. Just because this is a left tail test, we will be finding the area to the left of that test statistic value. Let's show that on a diagram. All right, so we have our curve here. Again, you do not need to show reject and do not reject regions for p-value diagram. All you need to show is where your negative 1.38 would be located. If this is the center of the curve, then negative 1.38 would be to the left, maybe somewhere here, I don't know. All right, let's mark it here. Negative 1.38, and we want the area to the left, which will be the p-value area. All right, it's a one tail test, it's a left tail test, therefore the p-value, the entire p-value will be on the left hand side. Okay, so that area is 0.083. Okay, this area is 0.083. Again, I used my table as well as my graphing calculators. Both gave me approximately the same value for the p-value. So p-value, oops, hope I don't lose it. Okay, so close it here. So p-value is 0.083. That's the probability of finding a test statistic value of negative 1.38, assuming the null hypothesis is true. All right. So now we compare p with alpha. All right. So the question we are being asked is P less than alpha? If it's less than alpha, then we reject the null hypothesis. So P has a value of 0.083 and our alpha value was 0.10. So 0.083 is less than 0.10. Because it's less, we can reject the null hypothesis. And just quickly double check that your p-value approach decision gives or is the same as the critical value approach decision. Both should be the same, but both should be in sync. So we have to say our decision, I'm just going to write here, decision is reject null hypothesis. However, we do need to interpret it. Interpretation should say at the 10%, all right, alpha equals 0.10 means significance level is 10%. At the 10% significance level, the data do provide sufficient evidence to conclude that the population proportion is less than 0.3. Is less than 0.3. That means our alternate hypothesis is considered correct. It's our evidence was strong enough to reject the null hypothesis and have it replaced by the alternate hypothesis, which says it is less than 0.3. Okay, so that's how you're going to work on the hypothesis test questions of one population proportion.